whenever we need a growth solver or an infection solver, we have to use the solver node, right? And we have to get some attribute where the growth begins, and then we need a solver node and the near points or PC open or attribute transfer. Everything works, right? And it's easier, right? But it has few problems. I want this whole thing to be completed at frame number 71 or 72. Yeah, we can just tweak the distance or points, but it is not controllable, right? So we can use some soft approaches, right? For an example, this one. So let's say now we can see how this growth works, right? Then we can tweak frame number it ends, we can tweak the width attribute, we can tweak the noise that is happening, all in real time. And this is quite controllable, and this is what I use my latest gig in a series. So what we need is a gradient from 0 to 1. Okay, so for an example, see that D, you can see the points are in here 0 0 0 going in this direction, this gradient is going this direction, this gradient going this direction. So that is the bare minimum we want. And then we need a logic to animate this. Let me just first give you some of the basic things that you need to get before getting started. Okay, so let's take an attribute triangle. Let's just get the gradient, just a simple gradient, nothing complex. We will not make the distance gradient for now. Let's just make a simple gradient on the x-axis, right? Now let's take a vector rel pbox 0 at p, and then I can just take a float grad is equals to rel float. And if we see this gradient, you can see this is going 0 to 1. Then we want to animate it, right? So first we need a frame range, right? So I can load frame. We can just say fit range. And I add frame number from some minimum frame to a maximum frame to 0 to 1. And let's make a ramp pad so we can control the speed of it as well. Then we need a width that I can, control the smoothness of my growth. Then we need to make sure it fitted between the value so the gradient will work properly. So what I can do is a float, or let's just get the frame number is equal to fit 01, my frame number from 0 minus to 1 plus. And then we need our actual animation. So we can just say fat animation is equals to fit my gradient from frame minus width frame plus width to 0 to 1. If we see this animation, so if we go with the color node, and in here let's just say I want from frame number 1 to frame number 50 and with the point 1, and let's just get the ramp from attribute and let's put it the animation. Now let's see it's inverted. So what we have to do is see one minus or not in here but in here 1 minus. Okay, so you can see the thing is working, right? And then we can change the speed, the ramping, and all of that in it. Now, this is pretty boring, right? But we want to have the noise as well. What we can actually do is pretty simple. So what I can say is in here, noise is equal to that a noise at p multiplied by CHF frequency by 0.5 and 1. And this would be our noise, right? And then what we need is just make frame number go slower or faster a little bit. So we have this noise, right? And then what we can actually do is just power up my gradient, right? So I need this part of my gradient go faster, this part of the gradient go slower. So we have to do just a simple trick. I can say grad is equals to power of my gradient with 01, my noise is CHF. I can say minimum noise is CHF, maximum noise. Okay. Then what we can do is take a frequency to let's say 3, minimum noise to 0.5, and now if we do this one, now we have this noise, and then we can control how much we want it, right? I mean, this has some things. Now you can make the attributes, or make a noise in here and just use this in here. So for an example, I can take a noise attribute. I can name this as noise, and in here I can use the FN noise. So now we want to have actual gradient of these ones, right? So now for the gradient, I will show you some of the things that we can do. There are many ways to make the gradient, some of the soft nodes, some with their angles and all. Okay, so the first one would be distance along geometry. Now you need some start points to have the distance attribute. So if I just get this one and just take a few points and enter. Now if we see the distance attribute, then you can see what is happening in here. But the distance isn't normalized, so we have to normalize this. I can take an attribute promote and set it detail attribute, and then I get this distance. I have maximum, the original. No, I can take an attribute triangle. Instead, this is equals to bit range. The f add dist from 0 to see it from the detail 0 dist. Now you can see the distance is normalized now. Then copy this triangle of mine, and rather than doing this one, I can say f add. Now it's this one, this one. Now you can see how this is looking, right? Okay, I forgot about the noise, like this one. So now you can see how this is looking, right? Now, this is with the shop node, so you can, just get this one. But I will show you the Vex way as well. So I can just take an attribute triangle. First one, and the second one is the points. So, in here, we can, specify where the growth starts, and then we will go over it, right? So first, we need a maximum distance that we can have, right? So, which is pretty simple. I can just take a float, length is equals to get the box size, and I'm gonna just take a length of this one. And then we need a PC open. So let me just integer handle is equals to PC open 1 p at p the distance, which will be our length, and pt will be 1, let's say. Okay, then we can have a vector position is equals to pc vector the, let's say, a mic handle, and let's say p position. Okay, and then we can get the num found pc num found handle, then we can say flow distance is equals to distance of the p, and then we can get distance. First, let's take the distance, multiply equals found, and then I can say fit range the distance from, let's say, 0 to length 0 to 1. Okay, so you can see how my now I don't need to do a distance and all of that. I just need these ones attribute that is going on, like this one. I can tweak the parameters and all, and now we have this one, all this. For this type of thing, I make this HTA. So this is for some web series that I made this one. So yeah, through animate, and I can just plug this right in and points in. And we have many options in here. So all the position mask. So if I say X mask and visualization mask, and this works something like this one, right? And I can add the noise for like this one. I can go with a Z mask. I can get the custom mask which I have, or by distance on the second input. And this work on animated geometry as well, and it is pretty fast. So if I get the drag, and I just not shader, and I'm gonna unpack this. After the unpack, I can do with the HBX, Pro Animate, and Visualize Mask, and I can say Y Mask. And you can, just see like how fast it, use real time and all of that, right? And I can enable the noise as well, so it works. So why not end this video with an example? So this is the Dune growth that is happening in the movie. So just the growth part, not the explosion and the destruction part. So you can see the pulsating that is happening in here. So this is still an R&D, so it is not perfect. But yeah, let me just show you how to do this one. So I have the geometry scattered bunch of points. This is the edge that I have, and I'm just taking the sphere in here, and just for having a growth like this one, and then I'm time shifting it for the d attribute, which is just a distance from the sphere, and after that I'm just transferring that attribute to the scatter, and then a noise, and this is the sum of the things that I have to do for the pulsing and the dissipation of the growth. So till here the concept is same, that we are just getting the gradient, age, width, animation, right? And then we need another gradient which have the pulsating effect. So I'm just getting the curve view, which is just a gradient actually. So, and then I'm just moduling it. And then after that, I have this pulse attribute. If we see the pulse attribute, second, this looks something like this. So, wait, so this looks something like this. And this looks pretty cool, right? And then after that, doing the same thing, but for the dissipation mark. So it actually disappear after some time, so you can see what is happening in here, right? And then just transferring the attributes and just multiplying the anim with it, and then have a density attribute. Same thing for the fiery element inside in here. I'm just getting the growth, time shifting it to 4 frames, and then have the dissipate attribute multiplication. That's all. After in the volume warp, it is pretty simple. Just getting the B box, getting the center point of this one, getting a distance from the position, and then turbulent noise, two turbulent noise, and adding that, and have that as a sample pose in a volume sample, right? And same thing with this one, and just import the volumes, and in the material for the smoke and the smoke lag. Smoke lag is the fiery one, smoke is the blue one, and we can go in here and see what is happening, and just getting the density attribute, arranging it, and then multiplying it for the color. After some multiply and the constant for the corrections of the volume, and then I'm just putting that into the emission, right? After that, the smoke lag is pretty similar as well. So I'm just getting a density, the lag fire attribute, and then just multiplying this as a fire color, and then power, multiply, same corrections, and then plugging it into the emission. So this is the result that we have, right? So that's all for this video. Bye bye.